Okay, welcome to part two of graphing rationals. This one is only about Pearson. 4.3, 4.4. I want to keep this video short because nobody wants another movie, all right? Or at least a video that's more than 22 minutes long. So we're only going to cover two questions really. Question one, which is the simple graphing based off of the parent functions you should remember. So before we begin, please take out the worksheet that has not only the parent functions, but the steps to graphing a rational function. On the test, you will not be graphing those crazy rational functions, just these simple ones, but you will be asked to find almost every component, okay? So let's begin. For this first one, let me just take a little quick snapshot here. All you really need to know is you have to remember that ultimately this is a parent function of 1 over x. All this 1 over x is doing is shifting down 1 unit. This, if there was an x minus 2, x minus 3, that would have been shifted horizontally, but it doesn't. So it's only shifted down. So really, what you should know now is that this shifts to the -1, and your vertical asymptote does not change because it only shifted down, right? So you really have a horizontal asymptote there, and your graph should really be just this right here, okay? So this, by knowing this, you should now know the domain and range, right? Because that's always going to be a follow-up question. So let's just go ahead and figure that out before we actually get into that. So the domain is literally all of this except wherever your vertical asymptote is, which your vertical asymptote has not changed. It's still at 0. So really, it's all real numbers except 0 for your domain. Now for your range, let's take it back a little bit here, is going to be scanning down up. So guess what? What number are we going to skip? Well, the shift really, because your horizontal asymptote is now at y equals 1, and that's the number we skip. So it's really, for range, it's all real numbers except -1. So be cautious about asymptotes when there's a shift, okay? That's really the biggest obstacle you have here. So with that being said, again, this is the parent function that shifted down 1. So let me see if I could figure that out real quick. I think it's this one. No, that shifted up 1. So I don't know, maybe this one. That actually shifted to the right some. These are so small. Ah, this one. This should be shifted down 1. So it should be B. Come on. Okay, check answer. Nice. So again, the domain, there was no horizontal shift. So really, it's all real numbers except 0. Okay? Hit enter. Good job. For the range, what is the range of the given function? Again, this shifted down. So had there been no shift, it would be all real numbers except 0 again. However, because there was a vertical shift down 1, it really is all real numbers except, you got it, -1, right? So that's because we have to consider the fact that it shifted down 1. All right. What are the vertical asymptotes? Okay. So again, this one's pretty straightforward. Set your denominator equal to 0. And you don't even have to set anything to 0. If you truly remember the parent function, we realize that the vertical asymptote is still at 0 because it did not shift right, left, or right. So x equals 0. Let's not do baby steps, okay? Again, x equals 0. If you're really struggling with any of this, please slow down, do it. Graph your parent function, realize that nothing shifted left or right, it's still at 0. However, your horizontal asymptote did change, right? Originally, your parent function is at 0, but this shifted down 1, so your horizontal asymptote is down 1, right? So -1. Okay, if you're freaking out, number 7, we're going to have to do it because there's a little bit more work. But for now, that's your goal, is to not have to do much math. Just write it down based off your parent function and your transformation. Real straightforward here. Quick reminder, if there is a horizontal, there is no oblique asymptote, okay? We rarely, especially on the test, we will not deal with oblique. Okay, so sorry if there is one here. If there is one, just skip it. Don't worry about it. You're still going to get most, if not all, of your points, okay? All right, so again, I wish I could do the rest, but I'm really just gonna jump to 7 here. I'm trying to keep this video short. So, okay, let's get to the real problem here. This is, again, the gist of this is for you to not only get the concepts, but really know how to do this on Pearson. I know it's a headache, but that's life. Okay, so this one, is it already in factored form? No, that's part of the challenging part, right? This is not factored. In fact, we want to factor it using, so what we need to factor is the denominator. X squared plus x minus 12 is not factored. So this is where you use Wolfram alpha, right? Let me see if I could quickly adjust this. I was trying to work ahead so I don't have to spend so much time typing here. So if you notice, it tells you right there the factor. So what you need to do is rewrite it. Write it on a separate sheet of paper. Don't try to do this Pearson, off the top of your head. It's not going to go well, right? You're going to take a lot of time trying to do it. So x plus 3 times x minus 4. So really, again, what I'm imagining is rewriting everything now. Okay, I will pay respect to the fact that I'm writing this here, and I'll refer to it as we move on. So unfortunately, this is the tedious part even for me. So I believe this was -3. And then the next one is x plus 4. Close the parentheses. And hopefully I got it right. I believe so. All right. Beautiful. Now it's factored. Now we're fully factored, right? So this is what that means, right? We broke down the denominator into 2 factored, x minus 3, x plus 4. Okay. So what is the domain of R of x? So again, domain is only affected by the vertical asymptotes. You technically could already see it. So my vertical asymptotes are going to be the denominator set equal to 0. So I could see that it's actually going to be A, all real numbers except 3 and -4. But if you really want to see the work, I'll show you real quick. So again, x minus 3 equals to 0. So you set, well, let me show you more formally. Again, we've done this, but why not? X minus 3, x plus 4, set equal to 0. That means that you set x minus 3 equal to 0 and x minus or plus 4 equal to 0, and solve for x. So on the left you end up with 3, and on the right you end up with -4. Okay, again, pause the video at any time if you really need to take your time doing this. So again, our domain is all real numbers except, I lost myself there, except -4, comma 3. I believe, let me just double check real quick. It should be that. Cool. All right. So is R of x in lowest terms? Let's look at this factor form. If you look, you cannot cross anything out. X squared does not cancel with anything, and x minus 3 does not cancel with anything. So end of story. It's already lowest terms. If you could cancel anything out, just look. When it's in factor form, it's easy to tell if you could cancel anything out. Find the intercepts. I believe this is number 3 on your steps to success. By the way, I will try, if I can remember, to insert the link in the description that includes the notes in case you lose them in the future. Because just to remind you that the final is cumulative, so you don't want to lose your work. So continue to stay organized. Okay, so finding x and y intercepts, I'll do that real quick using, again, you could use the top function or the factored form. So you could either use this one or this one. I'm going to use a factored form. So to find y-intercept, you plug in 0, right? And then you do the math. But I can already tell that the 0 is in the numerator, therefore everything is 0. So my y-intercept is going to be 0, 0. Or for Pearson, it's just 0. Okay? So if you think this was undefined, it's not. Undefined means that the denominator is 0. So now we have our y-intercept at 0, 0. Now, we need our x-intercept. If you look at the notes, x-intercept is set your numerator equal to 0. So what value of x squared gives me 0? Well, there's only one. It's only going to be 0. Okay? So you really just have one x-intercept and one y-intercept, and it's really just 0. So you should be able to put both of those for y and x, really. So if we go down here, it has an x and a y-intercept, and they're both 0. It says to enter an integer, so just 0. No x or y. And there you go. Okay. Awesome. So determine the behavior of the graph at any x-intercepts. This is where you got to be careful. So how did we get the x-intercepts? Well, we got the x-intercept by setting the numerator equal to 0. So it's asking what's the behavior at the x-intercept? Well, we only have one. So at x squared, okay, we got 0. Okay, so what's happening at 0, 0? Well, at 0, 0, in order to get this, we had something that had a multiplicity of 2. And if it has a multiplicity of 2, like this just had, because it was squared, then your graph is truly somehow bouncing at 0, 0. So it could be bouncing like that or bouncing like that, because it's an even degree. Had it been just x, so x had it just been x equals 0, not x squared, it would have crossed somehow at 0. So just to write an answer for that, don't get carried away too much on that. So the graph will cross or touch. So it's either B or C, actually, because there's only one x we need to worry about. So it will touch but not cross, because we had our x-intercept have a multiplicity of 2. Again, had it been 1, it would have been the graph will cross at that x-intercept. We're almost there. Determine vertical asymptotes. I am not going to set everything equal to 0 because I already did this earlier in the video. Again, what you're doing is setting your denominator equal to 0 and solving for your x's. So we have two vertical asymptotes. One at 3, because 3 makes it 0. And then one at -4, because that would make that 0 as well. So we have two vertical asymptotes, one at 3 and the other one at -4. So we have two asymptotes. The left one, which is the most negative, was -4. Okay. And the rightmost was +3, I believe. Unless I got that wrong. I'm going to double check right now. -4 and 3, is that right? Yeah. So the leftmost was -4 because that's the most negative, and then 3 is the rightmost. So that's what we have, right? What the? No. Oh, see, this is where we pause and we started getting a little ahead, right? Type in equations, man. That's what it says. Read the bottom. X equals. I was like, boy, I'm not wrong. Pearson is wrong. Anyways. So leftmost is x equals, and then you got it. Don't mess up like me, man. Be somebody. Alright. Alright, this is actually the most complicated one, and I'm gonna just say it flat out. It's either really going to be B or C, but I really want to show you. So right here, you should be pausing. If you really want to know how to do this, you want to pause here and then refer back to the graph we're going to be looking at right now. But it approaches either infinity or -infinity on both sides. Let me show you what that looks like. So approaching... Actually, let me show you by just doing this. Approaching infinity or -infinity. So let's suppose we have a graph, okay? Let's suppose also that we have an asymptote here. So for B, usually it approaches either infinity or -infinity on both sides. So let's say we had a graph, it would have to behave like this. It would have to have gone like this. So that's positive infinity. But it also would have had to gone like that. That's also positive infinity, because they're both pointing up, right? What we really care about is up and down, not really side to side. So they're both pointing up. Therefore, it's it's approaching infinity or negative infinity. Suppose we had another asymptote over here. How would negative infinity look like? They would be both facing down. All right, that's that case right there. That's B. So now what does the other case look like? Well, the other case would be C, and it's approaching infinity on one side and negative infinity on the other. So on one side it'd be going up, and on the other side of the asymptote it would be going down. And vice versa, right? It doesn't have to go up first, it could be going down, but the other side is the reverse. That is KC. That's exactly actually what we have, and we'll confirm that right now. So again, pause the video if you need to, soak that in, shower yourself with that knowledge, and then let's keep going. So, it is a little complicated, so don't get carried away with this part. So let's go to, I think this is the graph. Let me double check here. Squared minus 6 minus 12. Well, yeah, it looks like it. Okay. All right. So check it out. We have those asymptotes here, and look at the, okay. So we have these here, and if you notice, just look on one side of the asymptote and then on the others, right? So I'm looking here and then I'm looking here. They're the opposite, and then I'm looking here and then here. So these are the opposite ones. So it's the second case we talked about. So it's actually C, right? So it approaches infinity on one side, and all you have to do here is list the asymptotes. And you already kind of did that. Let me see if I can go up. You're talking about the vertical asymptote, so you're really using these two values we had from the previous part. So -4 and 3. So -4 and comma 3. Perfect. Should be it, I hope. There you go. So I hope it really helps. I'm sorry it's so confusing on that part, but just keep trying. Determine the horizontal asymptotes if one existed. So horizontal asymptote is based on the degree. Now, let me just scroll up here, and I want to prove something to you. Because you want to look at the highest exponents, you really don't get that right away off of this. So the highest degree is based, the highest degree is best off of this function here. So let me explain real quick. Remember, the degree is based off of the term with the highest exponent. So for the top we only have one. For the bottom, it's this one. The rest don't matter because they didn't have the highest exponent. So now we go and look at the rules. What's the degree of the bottom? 2. What's the degree of the top? 2. And one of the rules says that if they both match, your horizontal asymptote, horizontal asymptote is the ratio of the top divided by the bottom. Now we didn't have a number there, so therefore it's just 1. So your horizontal asymptote is just y equals 1. And we're done there, okay? So again, that only happens when your degrees are the same. So we go down. I don't want to mess up this time like I did before. It is going to be an equation. So it's y equals 1. All right, y equals 1. Sorry, it looks like it's going to be a long video already, but I'm pushing through. Speed it up if you need to, okay? Determine oblique asymptote. Again, no oblique if there's a horizontal. Nice work. Determine the points, if any. Okay, this is again the weird one. Determine, if any, at which the graph intersects the horizontal asymptote. Literally, all you have to do is set your horizontal asymptote equal to the function itself. So I'm gonna go ahead and snapshot that. Literally, just set that equal to 1, right? And just solve. And you'll see it's not that bad, hopefully. But again, if you really want to solve for x, you could literally take this equation here and type it into Wolfram alpha. Sorry, let me be specific here. Type in this equation into Wolfram, and it'll solve it for you, okay? Excuse me, but let me show you that it's not that bad. So again, you multiply across like that, and you end up with x squared equals x squared, because it's just 1, plus x minus 12. Okay, it was just 1, so it's just really itself. So if you do some math, all you really need to do is solve for x. But anytime you have this case right here, you'll realize that these cancel out. So that cancels out with that, and on the left, we just have 0. Anytime you cancel something out on one side and you're left with nothing, it's literally 0. But on the right, we're left with x minus 12. So let's move 12 to the other side because that's the one that's negative. So x is going to equal to positive 12. So when x is 12, this is going to ask for a coordinate. So when x was 12, what was my y output? Well, my y output was whatever I set this equal to, okay? It was my horizontal asymptote, which is 1. So my answer here is 12 comma 1. Okay, again, stop it here if you need to, but all we did was set, in order to find that intersection, we set the function equal to the horizontal asymptote, and then we just did math. Again, this is just another one that you shouldn't get carried away and just push through. So there was an intersection here, and again, it's requiring an ordered pair. So we got 12 comma 1 for this one. So I'm going to write that ordered pair 12 comma 1. I'm tired of math too. Sometimes I just get tired. Okay.